Hey everybody, my name is George Runkle and my company is Runkle Consulting Incorporated. Among the things that we do, we prepare structural designs for buildings made from shipping containers. And in this video I'm going to go through one that I already profiled. It's a vacation home that I'm working on for an architect that I work with frequently, Kelly Davies of Travis Price Architects in Washington, D.C. And this is a vacation home in West Virginia. We've made some changes since our last go at it, and I'd like to go ahead and cover that. So here we go. In my last video on this project, I talked about how we were going to make this vacation home out of shipping containers. It's built around an existing one-story modular building, which isn't shown in here. It's taking up this interior area in here. And this is being designed for a client of mine, Kelly Davies, who's with Travis Price Architecture. And we've collaborated on a number of projects, in particular the Seacon project in Washington, D.C., which is a 3-story apartment building for student housing made from shipping containers. Anyway, let's go ahead and get started and talk about what has changed here and what we've done. One of the things that we've done is Kelly asked me to change the roof joists. I had originally the roof joists were 2x10s, and it was the major issue on there was to try to keep the cost down, but she needed 12-inch deep joists to accommodate the insulation she wants up here. So I changed them to, in discussion with her, we changed these to wood eye joists. And here's one that's a little bit skewed here. I got to fix that. I'll fix it later. But anyway, we changed these to wood eye joists because they're much flatter and we have much more flexibility with the length of them than we do with 2x12s. Also, 2x12s are fairly expensive, so the price is kind of converging on the two types of lumber. And what I did here is in the center part, I've got these spanning 40 feet, but I'm giving the framer the framing supplier the option to splitting up the lengths. I've got beams underneath of it that are at 5-foot spacing, and that gives us a lot of flexibility of how long we want to make these joists up here. We can go with 2 20-foots and overlap them over the center or whatever that they happen to have in stock possibly. The other thing that was changed is the idea these beams were originally going to be tree trunks, but that doesn't work. A tree trunk starts out rather wide and gets narrower as it gets to the top, and it has all kinds of imperfections where it's not the same width, and you got places where the branches came out, and you got all kinds of imperfections on the sides, and it just makes it a nightmare to try to frame these joists on top and keep them all at the same level. So we went away with that, and we're using 9.5-inch deep laminated veneer lumber, LVLs, using 3 of them in each location, and we changed the spacing to 5 foot on space, and originally they were sitting here on top of the columns. The columns here are the same. They are LVL columns, and I've got going across the top of the columns, which I've got to adjust the height here. No problem. Change the height. This should be at, let's see, where are we at? Top of column. Oh, okay. Here we'll change all of these to select all incidences visible in view, top level, and it will be fix it. Okay, good deal. Anyway, then of course down here we've got beams that are spanning across these LVLs. These are going to be supporting the windows that are going in the front. And let's go ahead and show what I've got inside here. And we've got a balcony that comes out, and what I think is pretty cool is we're using for a railing the railings in the container are being used, the side railings, which make a nice the side panels, cutting them off at about this height will probably cut this. There's a couple of ways that we can go about doing this. One way is to cut this section off of an existing container. The other way is you can actually buy on the aftermarket a bottom rail, and you can buy the corrugated panels, and then on the top it's capped with a simple 4x2 by quarter hollow steel section, HSS 4x2 by quarter, and it makes a very good railing. I've done it before on a project in Indiana on the roof of a project. And then we've got here the stairway that comes through, and it gets a little bit interesting here. I put a beam all the way across the top instead of supporting things on the wall, because I've got to carry this load through the floor of the existing building, which I don't have much information on. So what we're doing is I'm carrying all this load up here on this beam, then down through the columns here to a beam we're placing below the floor, so we can simply cut through the floor, put the columns through, and that's the parrot in the background. He likes watching Revit. Sorry about that. So anyway, that works out pretty good. One of the other issues that I had that was a real pain, which I have to show here, is right in here in this corner. We've got this container coming across here. And the problem I got is this wall is existing. It's a masonry wall. I can't put that corner on this wall. It just isn't going to carry it. I know. Yes, look at that. He likes watching this stuff in Revit. I'm sorry about that. You're going to have to hear that. He's enjoying himself watching me. So what I have here is a column that comes up, and the column I'm showing is concrete, but I'm given the option to use a masonry column in here instead, which may be easier to work with inside of this masonry wall. And we've got a couple of options which we can do. The other issue I had is I don't really have any topo outside, so I've got no topo plans outside, so I'm not sure what my elevations are of the ground outside of here. So I basically just designed it like it's 8 foot high, with having these piers and having the long columns coming up. The deck I'm simply supporting on poured sonotube foundations. I understand the ground is pretty rocky out there, so we don't need such big foundations. I've got some pretty large foundations elsewhere, but when we get into construction and they've dug down to what the material is below, we can make the foundations smaller if it is in fact all on rock. I can cut these down quite a bit. But for now, since I don't have the information, I'm just assuming nominal bearing capacity of 2,000 pounds per square foot, which is usually what I use when the soil conditions aren't known. And here in the front, we got the same. We've got a deck coming out. I'm not showing the railing on the deck. I'm going to leave that up to the builder, since the prescriptive code for deck construction shows exactly how to build a railing. I'm going to go with that rather than detail that out on my plans. I stuck to what's not in the code, and here we've got the same deal. This is going to be treated columns, treated lumber all across here. So this gives us, from the 3 dimensions, we've got our different views here. Here's our foundation plan. with the detailing for different stuff I had to do. And then first floor framing, second floor framing, which we'll pull up right now. Second floor framing, roof framing, and I've got here in the hand our various details to be going on. What I kind of like about using Revit for doing this instead of traditional CAD is I'm able to get the kind of detail in the drawings and the graphics that we used to get when we drew by hand, which is lost in AutoCAD, but now it's come back with Revit. You'd never would get a set of drawings looking like this in AutoCAD, but in Revit this looks good, and this is what you would do with pen and ink back in the day. And I really think we lost something when we went with AutoCAD and went away with pen and ink. The only thing is that now that we're back into using Revit, or even with AutoCAD, the advantage was the engineer could actually do the design drawings instead of a trained draftsman. It took a lot of work to get to the point to create a drawing with pen and ink, a lot of skill which most of us engineers just didn't have. I never got it. I could draw with pencil, but my drawings in pencil look kind of hokey anyway. But I'm able to do very professional drawings using Revit because I haven't had to build up the skill of holding a pencil. That's some serious skill in the days when we did hand drafting, of trying to build up the skill to hold a pencil or hold a pen in your hand and develop that muscle coordination with your brain to do the drawing. You might know exactly what you want to draw, but until you've done it over and over and over again to build that coordination, it's going to look like garbage. But you don't have to build that same kind of coordination using the computer, although you do have to build up a different type of coordination, which takes quite a bit of time to learn too. So I don't know, is the learning curve higher on CAD and Revit? I spent a long time learning CAD and Revit and taking a lot of courses. Would I have been able to do the same thing if I put the same effort into drafting? I don't know. Hard to say. But anyway, I like this drawing. I like the way these come out. And these things, a lot of the stuff will generate itself from the sections you pull. You don't have to do a lot of the drawing. Lettering is really good. That in the old days when we did hand drafting, lettering was very hard to learn, at least for me. I never even came close to mastering it. Yet here I just type it in and the lettering looks nice. And where I showed that column, here's the option where we're going to go with a just a concrete masonry unit column. It's pretty simple, just two blocked together to make it a 16 by 16 inch column. Reinforce each cell with a number 4 rebar, 3000 psi concrete. Works pretty good. All right, so that's where we're at. I hope you enjoyed this video, and if you like it, please give me a like, and we'll put more up on like this. Thank you very much.